We are now on DNS, the domain name system. DNS, the domain name system, is a hierarchical method of organizing computers into domains. For example, all of the computers at Microsoft are grouped into the Microsoft domain, which falls under the .com domain. And all of the computers at the Community College of Baltimore County are grouped into the CCBC MD domain, which falls under the .edu domain. The top level domains include .com, .gov, and .edu, and secondary level domains might include Microsoft and Walmart, which fall under .com, or Harvard, Howard Community College, and the Community College of Baltimore County, which all fall under .edu. Why do we need DNS? Here's the example. Howard Community College's web server is named www, and our web server here at the Community College of Baltimore County is also named www. So how can we differentiate between the two? And the answer is using DNS. Howard Community College's web server falls under Howard Community College's secondary level domain, which is HCC, which falls under .edu. And our web server falls under our secondary level domain, CCBCMD, which falls under .edu. Howard Community College is named, Howard Community College's web server is called www.hcc.edu, and ours is called www.ccbcmd.edu. Host name and fully qualified domain name. What's the difference? The host name is the name of the computer, such as Server 1 or www. That's what they usually name web servers, or mail. You could name a server anything that you wanted to. A fully qualified domain name is the host name plus the DNS suffix. So, for example, mail.ccbcmd.edu or server1.howardcommunitycollege.edu. Host name and fully qualified domain name. The Hostname Command allows us to view the computer's hostname, the name of the computer. To do that, we go to the command prompt and we type hostname and we press the enter key, and that shows that the name of this computer where I am right now is called workstation-cat, which is short for Catonsville.h124, which is the room that this computer is in. Now, let's discuss DNS hostname resolution. We are going to look at several things that you're already familiar with. What is a DNS client, which is simply a user's workstation? We look at a web server, host name, packet, IP address, all of which you are familiar with, and what we're leading up to is the DNS server. So let's look at that. At CCBC, we have a web server, and it has an IP address of 10.0.0.5. And of course, the host name is www.ccbcmd.edu. And if a user wanted to, the user could access this web server based upon IP address. The user could type http://10.0.0.5, presses the enter key, and the IP protocol sends a packet off to 10.0.0.5. Now, how does the TCP/IP protocol know to send the packet to 10.0.0.5? Well, that's easy. That is what the user typed in. But usually users do not type in the IP address. They do not access web servers by IP address. They typically access web servers based upon host name. So the user would typically type http://www.ccbcmd.edu and press the enter key. And then the IP protocol would send a packet to the web server, which is 10.0.0.5. Here's the question. When the user types ccbcmd.edu and presses the enter key, how does the IP protocol know to send it to 10.0.0.5? And the answer is DNS. A DNS server is a server that contains host records. And a host record is a name of a host name, name of a web server, and its corresponding IP address. So the DNS server has a list of all of the web servers and their corresponding IP addresses within the organization. So when the user types ccbcmd.edu and presses the enter key, the user doesn't know it, but the user's workstation is sending a signal to the DHCP server to find out what the IP address is of ccbcmd.edu. This is a query. The workstation says to the DNS server, what's the IP address of ccbcmd.edu? The DNS server sends that IP address back to the workstation, and now the workstation knows the IP address of ccbcmd.edu, and the workstation sends the packet off to the web server, and of course the web server sends its web page back. This whole process is called host name resolution. The user at the workstation or the DNS client wants to access a web server, so the user types the URL or the host name. The workstation then queries the DNS server to find out what the IP address is. The DNS server has a host record, and the host record is the computer name and its corresponding IP address. And then the DNS server tells the DNS client this is the IP address of the web server you want to get to, and now the workstation knows the IP address of the web server the user wants to get to. This is called host name resolution. DNS forwarding. DNS forwarding occurs when a user tries to access a website which is not in the local DNS domain. For example, a user at CCBC tries to access www.contoso.com. Well, what happens is the CCBC DNS server forwards the DNS query up to the root server, which forwards it to the .com server, which forwards it to the Contoso DNS server. Here's a diagram. The user who is at CCBC is trying to access www.contoso.com. User presses the enter key. The workstation queries the CCBC DNS server. The CCBC DNS server pushes the query upstairs to the root DNS server, which then pushes the query to the .com DNS server, which then pushes the query to the Contoso.com DNS server, which provides the IP address of the Contoso.com web server. This is called DNS forwarding. Now, let's look at configuring the DNS client to point to the DNS server. And what we mean by that is whenever a user types a host name or a URL, we want that query to get pushed to the right computer, which is the DNS server. So we have to configure the workstation to push all DNS queries to the DNS server, and we have to get the right IP address. In this case, it's 10.0.0.150. So I go to the DNS client, the workstation, and under the TCP/IP protocol configuration screen, you already know what IP address is and subnet mask and default gateway. But then we go down here and we configure the IP address of the DNS server, which in this case is 10.0.0.150. And what that does is that causes the workstation to forward all DNS queries to the server with the IP address of 150. Now, if you make a typographical error here and you type in 159, then when the user has a DNS query, it's going to get forwarded to 159, and there is no 159. So it's important that the DNS client is configured with the right IP address so it will push its queries to the DNS server. The main point in DNS is that the DNS client asks the DNS server the IP address of the web server that the user wants to get to. Do we really need DNS? If people could remember the IP address of every website they ever wanted to go to, then we would not need DNS. But we do need DNS because most people can remember names but not IP addresses. DNS troubleshooting. If a user cannot access a web page, we have to ask the question, is the problem with IP, with the routing, or is the problem DNS? Here's the example. The symptom is that I can access a web server using the IP address, but I cannot access a web server using the host name. So can the problem be that the web server is down? No, I can get to it, but just by IP address. Is it a faulty router or a switch? No, I can get to the web server by IP address, but not using host name. Therefore, this indicates that this is a DNS problem, not an IP problem, and not a routing problem. So once we've decided that it is a DNS problem, here are the potential possible causes. 1, that the DNS server is down. Or 2, that the DNS client is not pointed to the DNS server. Or 3, there is no host record on the DNS server. Remember, the host record is the web server's name and the corresponding IP address. To determine whether or not there is a host record on the DNS server, we use the NSLookup command. The NSLookup command allows us to determine whether or not a resource record or a host record is in the DNS server. So to determine whether or not www.ccbcmd has a corresponding IP address in the DNS server, I go to the command prompt and I type NSLookup, and NS stands for name server. A DNS server is also called a name server. NSLookup space www.ccbcmd.edu, and I press the enter key. And then we see, yes, there is a host record on the DNS server that corresponds to www.ccbcmd.edu, and there is the IP address. This is the NSLookup command. DNS Server Replication. DNS Server Replication provides redundancy, which provides fault tolerance. If you just had one DNS server and it crashed, then your users would be out of luck. So we usually have a primary DNS server and a secondary DNS server. And every 15 minutes, the contents of the primary DNS server is replicated to the secondary DNS server. So if either one of them fails, that's okay. We're covered. We have the other one. Now let's look at the DNS client configuration. We already configured the DNS client to point to the first DNS server. So we go to the DNS client, and we've already configured the DNS client to forward to the first DNS server. Here is where we would add the IP address of our secondary DNS server. DNS Server Replication provides fault tolerance. In summary, in this section we talked about DNS and host name resolution. We saw that a DNS client, which is just a workstation, sends queries to a DNS server, and a DNS server has host records. We looked at DNS troubleshooting and at DNS server replication. And this concludes our section on DNS.